Welcome to the second indices laws video. If you remember in the first video, we gave you 2 out of the 5 indices laws. In this video, we're going to give you the remaining 3. Also, if you remember, we said that in this video, at the end, we would give you a few examples for you to have a go at on your own. I've decided to change this slightly, and instead I'm going to create for you a new video where I'm going to tackle a few more of the slightly more difficult concepts of indices laws. And at the end of that video, I will give you the exercises. The reason for this is originally I wanted to keep things simple, nice and easy, so that people aren't put off by anything. But instead I thought, well, you've already done indices, chances are you know all of this stuff off by heart anyway, you can do it in your sleep. So I've decided to make the exercises a little bit more difficult. And since I've done that, I need to create a new video where I've given you more difficult examples and where I'm going to explain a few more concepts which I haven't yet done. Namely, things like indices, which have fractional powers instead of whole powers. So far, we've been used to saying things like x to the power 5, x to the power 8, x to the power 4. All of these x's have powers to the whole number. But we're going to deal with, in the next video, indices, which have fractional powers. And we're going to learn that these indices mean something slightly different than indices which have whole numbers as powers. So moving on now, onto the content of this video. Now, if we take something like a squared times a to the power 4, what do we get? How can we simplify this? Well, if we break up this equation into its separate parts, write it out longhand, and then see what we get, we should come up with an answer. So doing that, let's take a squared. A squared is just a times a. A to the power 4 is 4a's multiplied together. And all we do now is we substitute what's on the right hand side and put them in and see what we get. So we see that in the end we have 6a's all multiplied together, and we know from our indices laws that 6a's all multiplied together can be written as a to the power 6. Therefore we have a squared times a to the power 4 equals a to the power 6. Nice and easy. Moving on, let's take another example. B to the power 5 times b to the power 6. We'll do the exact same thing. First, we'll write out b to the power 5 in longhand form. Take b to the power 6, do the exact same thing, substitute those in, and if you count all the b's, you'll find we have 11 b's all multiplied together, which gives us b to the power 11. Now, let's look at these a little bit more closely and see if we can see a pattern emerging. So here we have the first one, here we have the second one. Now focus on our answers, a to the power 6 and b to the power 11. Specifically focus on the powers. In the first one, you have the power 6. Now that 6 is simply the sum of the previous powers 2 and 4. With 11, that is simply the sum of the previous powers 5 and 6. And that's actually your indices laws there, and they're given already. All it states is, when you have two indices whose variable is the same, but which differ in their powers, then you get a new indice with the same variable with the power that is the sum of the previous powers. Now that sounds a bit confusing, but that's because I'm just using words. If you see it written down, all that means is if you've got an indice x to the power some number a times x to the power some number say b, all you get is a new indice x to the power a plus b. Now if you had another one, if you had a third one, so say something like x to the power a times x to the power b times x to the power c, then you'd get a new indice which is x to the power a plus b plus c. And it's as simple as that. That's the indice law done. So if we now go ahead and add this new indices law, we get so. And you can see we've done 3 out of our 5 already. Again, if it's a bit fast, I apologise. I assume you already know this, so I'm going a bit fast and I'm not spending as much time as somebody else might do, who would assume that you've not done this before. Moving on then. What if we do the opposite? Instead of timesing 2 indices, what if we divide 2 indices? Let's move on to an example of that. We've got b to the power 6 divided by b to the power 5. Just like before, we're going to write this out longhand so we can see what's going on. B to the power 6 equals 6b's multiplied together. B to the power 5 equals 5b's multiplied together. Substitute those in, and we can see that 5b's from the top cancel with 5b's on the bottom, leaving just 1b on the top. So this equals b. Moving on to our next example, we have a squared divided by a to the power 4. A squared equals a times a to the power 4 equals 4a's multiplied together. Substitute those in, and you can see that 2a's from the top cancel with 2a's from the bottom, leaving 2a's on the bottom, or 1 divided by a divided by a. Now notice in the denominator, we have 2a's multiplied together. Using indices laws, we can simplify that to 1 over a squared, or if we wanted to write it even shorter, we could say that's a to the power minus 2. Now, let's look at these two in more detail. We've got b to the power 6 divided by b to the power 5 equals b. A squared over a to the power 4 equals a to the power minus 2. Here, once again, let's focus on the powers on our answer. In the first one, the power is 1. And if you look at what's before the equal sign, on the top we have 6, on the bottom we have 5, and just looking at the numbers, we can see that 6 take 5 gives 1. In the second example, our power is minus 2. Looking at what's before the equal sign, we have 2 on the top, 4 on the bottom, and we can see that 2 take 4 gives minus 2. Now this is the next indice law. Expressed generally, it states x to the power a divided by x to the power b, where a and b are any numbers, equals x to the power a minus b. As simple as that. So now we can go ahead and update this on our indices laws slide. That's now 4 out of 5 of the indices laws, and now we're going to move on and go straight into the last and final one. Here we have a times b, or just ab, all cubed. Now keeping the parentheses here because that's important, let's go ahead and write this out longhand. We get ab times ab times ab. Putting all the a's to one side and all the b's to one side, we get a times a times a times b times b times b. Now using indices laws, we can split this up into two indices multiplied together to get a cubed times b cubed. So our answer, ab all cubed equals a cubed b cubed. Let's take another example. Let's take xy to the power negative 4. Now, first thing to do here is remember that an indice to a negative power can be made positive by taking its reciprocal. So 1 over xy to the power 4 is equivalent to xy to the power negative 4. Now using this, we can expand the xy all to the power 4 and rewrite it out longhand. So we get 1 over xy times xy times xy times xy. Again, putting all the x's together and all the y's together, you can see that we have 4 x's multiplied together, 4 y's multiplied together. This gives us 1 over x to the power 4, y to the power 4. Just as we've been doing, let's take a look at these examples and see if we can come up with some sort of pattern. You can see that whenever you have variables multiplied together, surrounded by parentheses, and then raised to a power, all that happens is this power distributes towards each individual variable. So ab, which are inside the parentheses, are both raised to the power 3. Therefore, we can rewrite this by having the 3 distributed between the a and the b, so we get a cubed b cubed. Similarly, with the xy, we do the exact same thing, and the negative 4 gets distributed with the x and the y, so we get 1 over x to the power 4, y to the power 4. Now you might be saying, well, why don't we get x to the power negative 4, y to the power negative 4? And the answer is, we do, but we've just taken it to its conclusion and put it in its best form. To illustrate this, here's a line which shows us going from xy all to the power minus 4 to x to the power minus 4, y to the power minus 4, and then using one of our indices laws, we just put it over 1 in order to make it positive, and we get 1 over x to the power 4, y to the power 4. We can express this law in general terms and say if we have variables multiplied together in parentheses, say xy, and they are all raised to a power, let's say a, that just equals each individual variable to that power. So we get xy to the power a equals x to the power a, y to the power a, and that is our final indice law. So finally, you'll see this slide in its entirety. Starting with the first law, x to the power a times x to the power b equals x to the power a plus b. The second law, x to the power a divided by x to the power b equals x to the power a minus b. The third law, which we've just done now, is x, y, all to the power a equals x to the power a, y to the power a. The fourth law, which you received in the last video, is 1 over x to the power a equals x to the power minus a. And finally, the last one is x to the power 0 equals 1. And there you have it, the 5 indices laws. I hope everything's been clear. The next video, we're going to be dealing with indices again, but this time, the powers that they are raised to are not whole numbers anymore, instead they are fractions, which complicates things a little bit. Underneath the video, you'll see a PDF with some exercises that I want you to have a go at. Have a try, you should ace them, and I'll create a separate video which goes through all of their answers. And upon completing that, indices laws is done and dusted, and we're going to move on